Poisson probability distributions, our third and last one for this unit. By the way, I give more detailed explanation in the notes on Brightspace. In these videos, I'm trying to get the main ideas across and do some examples so that we can actually punch them in the calculator and see how it works. The ideas, I hope I was clear in the notes, but I think this helps to actually see the problems done out. Alright, so we have the Poisson probability distribution. Its formula is here. The probability of some number x is going to be mu to the x, that's 2 to the x, times e to the negative mu over x factorial. Now that looks like pretty bad, but takes a little getting used to, but really there's, in the binomials, we had 4 numbers floating around in the equation. There's only 2 here, the mu and the x. So what do those mean? That is what's most important, is you know what they mean rather than memorizing letters. Mu is the number of occurrences on average, and x is the number of occurrence in this specific case. I put this in quotes because it's like when I'm doing a problem, x means the number in that particular problem, right? So, or in a specific time, we need to see some examples. Mu is on average, x is a specific point in time. Now the intervals don't have to be time, but we're going to do time because I think it appeals to us intuitively. If you take another stats class, the intervals could be volume intervals or area intervals, could be any interval. Intervals are a span. It's not one, like a time interval would be like 2 hours or 7 hours. How many times did something happen in 7 hours? That is a time interval. Okay, and the units have to match. We're going to do examples for that. So let's just start out with some thought kind of things before we get into the numbers. What is this talking about? An example to kind of put it into my framework, like my world, would be, let's say, my high school classes, that on average, 8 people go to the bathroom per class. Right? So first hour, 8 people go. Second hour, 8 people go. On average, 8 people go to the bathroom every class. I could ask, what's the probability that 7 people go next class period? See, now I'm going from the on average idea to specifically next class. What are the odds that 7 people go instead of the average of 8? See, that's what this probability distribution is made for, to measure if you know about something over intervals, what's the probability that in the next case, in this particular case, you get that number. So basically it's how these numbers bounce off each other. That's the average. Compared to that average, what are the odds of this happening? So what do I mean by this, where the units have to match? Well, let me rephrase this a little bit. Same idea, but slightly tweaked. Let's say that on average, I think I did 72. 72 people go to the bathroom per week. I know that might be a little bit weird saying how many people go to the bathroom, but I was just thinking of like what's a good example. Like as a teacher, like when I'm teaching in high school, there's always like, can I go to the bathroom? Can I go to the bathroom? So this one just kind of popped out to me. Sorry if it's a little weird. On average, 72 people go to the bathroom every week. Let's say that's true. What's the probability that 10 people go on the next Tuesday? Right? So this is how many people ask or go to the bathroom in a week on average. And this, I'm specifically wanting to know what are the odds that, let's say today's Monday, tomorrow, Tuesday, what are the odds that 10 people go over the whole day? See the problem here? This number is associated with a whole week, whereas this number is just one day. So that is a mismatch, and if I use these numbers, however you do that, I'm going to get the wrong answer even if I do everything right. So what I've got to do is I've got to tweak this. I either have to figure out, well, how many is this per day, or how many would this be per week? So I'm going to say, okay, if 72 people go per week, I'm going to do this as a conversion, but you could just figure it out like intuitively. There's 5 school days in a week, so 72 over 5, right? So 1 week, if I do it as a conversion, over 5 days, the weeks cancel, and I would get 14.4 people per day, right? But intuitively, if 72 people go in a week, which is 5 days, divide by 5. 14.4 go per day. So in this case, 14.4 would be my mu, that's the average, and 10 is the specific number I'm curious about. All right, so let's take those 2 examples and let's use that equation with those 2 examples, and then I'll throw in another non-bathroom example. But let's just, since I threw these out, let's see how the numbers play. So let's backtrack to the first question. I'm going to erase this here. I'll leave the equation on the board. So remember, on average, 8 people go every class, and I want to know the probability that 7 go next class. Well, what am I saying here? Mu is the average. Mu is 8 people per class. X is in what I'm wondering about in this particular case. That's the average. Specifically, I'm wondering, next class, what's the chances that 7 people go? 7 people go in the next class. See, they match per class, per class. See, so I'm going to plug these in. The probability of 7, see the X, is mu, which is 8, to the X, see mu to the X, times E. Now E is a button on your calculator. It is right here. It's the LN button. It's in the blue right above it. I don't know if you can see that. If it's focusing, but it's right there. It's the LN button. It's shift. So this is e to the negative mu, which is 8, over x factorial. Let's look at that again. See the x? Here, let's use colors. X, 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 x equals 7, 7, 7, 7. See it there? Mu, mu. Mu is 8. There's 8. There's 8. See how I'm just putting them right in the slots? So it's not bad. What you got to learn is if you see about intervals, that's a Poisson distribution. We got to use this equation. This cap is not going on. So it's on intervals, like per class, per day, per week. That's a time interval. And I got to know the on average number, that's the mu, and then I got to know the specific time interval, which is 7 in this case. So if I punch this in my calculator, I've already calculated it, but let's just do it together. I'm going to press 8 to the 7. And personally, what I would do is at the same time, I would press this, because the exponents can be large numbers, and your calculator might error on you, like it won't want to show it on the screen. This is going to be a small number all the time, so if you do those together, it'll make more manageable numbers. So I'm going to press second ln, and on my screen it says e to the, and I'm going to type in not -8, I'm going to type in -8, and I'm going to press enter. Now I have to divide by 7 factorial, so I press divided by 7, math, go to probability, and it's the factorial button is there, and I press enter, and my calculator is saying 0.140, actually 0.13958, and so on. So this is a 14% chance. Given the fact that 8 people go on average every class, the odds of 7 people going next class, there's a 14% chance. Well, our next one, it was like, 72 in a week. Let's see how that plays out. So remember, on average, 72 people went to the bathroom per week. What's the probability that 10 people go next Tuesday? Supposing, of course, we're all back in school on some particular Tuesday. We'll get there. Well, what am I seeing here? I notice immediately I have a mismatch. This is one day. This is a week. That's a problem. So I got to fix that. So we already did that. 72 per week. There's 5 days in a week, so if I divide by 5, that was 14.4 per day. So that would be my mu on average. If 72 go per week on average, then 14.4 go per day. See, I got to get it down to 1 day because the time units have got to match. So this would be my mu, and x would be the 10 on Tuesday, which is 1 day, right? So there's my mu, there's my x, there's my formula. So the probability of 10 is 14.4 to the 10 times e to the negative 14.4 divided by 10 factorial. So I'm going to have to erase this to write, well, I guess I can write my answer right here. So 14.4 to the 10 is going to be a big number, but I'm going to put in, before I press enter, times second ln, which is e to the negative 14.4. And then I pressed enter. And now I'm going to divide by 10 factorial. 10 math, probability, factorial. And I get 0.059 or 0.058887. So that is about a 6% chance that 10 people would go on Tuesday if 72 on average go per week. We're going to do one more example. I want to say this about the test, though. On the test, I am going to be making it available to you on Brightspace. So you're going to open it up, you're going to answer the questions, and you absolutely can have the formula. I'm not concerned about you memorizing the formula. I couldn't enforce that even if I wanted to if you're taking this at home. Really, though, my concern is not memorizing the formula. It's that you know how to use it. So be sure you're practicing these. The way to make sure you're going to do well on the test is you're doing practice problems and you're making sure that the answers are actually coming out the way they're supposed to. All right, having said that, let's do one more example. We'll do it where we have to adjust our units, and that should give you enough to go on, at least to practice. So this time I got to write a bunch of words because I got to set up the scenario. Suppose that 18 cars go through a car wash every 3 hours on average. Given that fact, what is the probability that 4 cars go through in the next hour? See, this is what Poisson distributions are set up for. If you have data on averages over time periods, then you can apply it to future time periods, right? And you can make predictions. What are the odds this are going to happen? You don't know for sure, but we can get a feel for how likely something is. All right, so I notice that this time interval is 3 hours, whereas this time interval is 1 hour. So we've got to make an adjustment. This is not a difficult one. I made the numbers work out nicely. So let's try to identify mu. Mu is the average. See, it says average. 18 cars every 3 hours. So I want to get it to be per hour so that these match. So I'm just going to divide that by 3. If 18 go every 3 hours, then 6 would go every 1 hour. So mu is going to be 6 cars per hour. This is nice to know, but what you really care about is mu is 6. X, that's the specific, like in the specific next hour, how many? I want to know the probability that 4 go through. See, those are the only 2 numbers I need. It's a little weirder, like I think than the binomials, like getting the hang of this. But there's a lot less stuff you got to pin down. You only need 2 variables. All right, I don't got a lot of room. I'm going to erase. So the probability that 4 cars go through in the next hour would be 6 to the 4 times e to the minus 6, e to the minus 6 over 4 factorial. So I'll type that in just a second. I have 6 to the 4 times e to the negative 6, and I divide that by 4 factorial, and I get 0.134. So 13.4% chance that this would happen. Let me just say, if you're doing this and you get a number that's over 1, then you punch something in incorrectly. That's why it's so important you practice these. It's very easy to type something in and get a wrong answer. You could be thinking just fine, but not inputting it in the technology correctly. So just be sure you're double checking on that. All right, that does it. The next thing that you have on your agenda, besides reviewing and getting ready for the test, is taking the test. That'll show up in Brightspace in the next couple days. I will talk to you soon.